Hello, back again. Today we're going to discuss Mat181 trig non-acute angles. This is section 2.2, page 54. And what we're going to do is we're going to look at certain reference angles and see what the heck happens. So what are we talking about a non-acute angle? Well, acute angles are in the first quadrant. Right here. And remember, when we draw an angle, we always project, this is the initial side, this is the terminal side, and we're projecting to the x-axis. We always project onto the x-axis. But what we want to do is, sometimes if we have a very large angle, we want to kind of write it in terms of a smaller angle. Let's try one that's kind of a good basic angle that we might get. Suppose we had an angle that was 225 degrees. 225 degrees going this way. Okay, we'll call that theta. 25. But we want a reference angle. We want an angle that's smaller than 225 so that we can kind of work with it instead of having to work with huge angles. So if I was to look at this angle in here, from here to here, let's call that alpha, for lack of a better name. And we're calling that alpha, and we're going to project down here. Okay? So alpha would actually be this triangle right in here. It would be from 225 basically to 180. So what is this angle in here? So how can I find it? Well, I can simply take 225 minus 180, and that would be 45 degrees. So if I'm talking about, let's say I wanted to find the sine of 225 degrees, it would be the same as the sine of 45 degrees. And if I use that handy dandy little chart that I told you to work on last time, what is the sine of 45? Well, that's radical 2 over 2. But wait, the sine of 225 is in what quadrant? The third quadrant. And we know that all students take calculus. We know in the third quadrant, only the tangent is positive. So the sine of 225 equals negative sine 45, which equals negative radical 2 over 2, because in this quadrant, the sine is negative. The tangent is positive, but the sine is negative. So the sine of 225 is the same thing as the sine of negative sine 45. Sine of 225 is negative radical 2 over 2. Well, the other question is, how did I know how to do this? So on page 55, there's a handy dandy little chart that we want to create. Here's our, if I can draw it, our big old baby here. Quadratic thing. The quadrants. Okay. 1, 2, 3, 4. So we're going to figure out a way to find those reference angles. So if the angle is in the first quadrant, doesn't matter what the angle is, it's always going to be the reference angle. It's going to be and reference angles are between 0 and 90. That's what we want it to be. Like you can have a 89-degree angle. That's great. You know, that would be our reference angle. It has to be an angle between. So reference angles are between 0 and 90 degrees. Probably greater than 0, hopefully, and less than 90. So these would be called our reference angles. Okay, so what if we're in the second quadrant here? And we have an angle in the second quadrant. Let's draw it out here so you can see it a little bit better. Draw an axis. So if I went all the way around like this, that would be in the second quadrant. We'd have an angle right here. Maybe I could draw it here. I use the red. This angle right here would be theta. Okay, that's in the second quadrant. But what we want is, we want this angle right here as our reference angle, because we always draw down. So our reference angle would be this angle right here. Thinking of this as a positive angle, or not necessarily positive, but a small angle as compared to this big angle right here. So how can I find it? Well, the book has a little easy way to remember. Theta would be equal to 180. Let's call it alpha. Alpha, this reference angle in here, would equal 180 minus theta. Let's say theta was 179. Our reference angle would be 180 minus 179. It would be 1 degree. That would be our reference angle. Also remember that all students take calculus. Okay, so only the sine is going to be positive in the cosecant. Tangent, cotangent. Cosine, secant. Okay, so that helps you. What if we're in this quadrant? What if we have an angle here? We want this is our angle right here. Our reference isn't here. Our reference angle is, again, drawing straight up. This is your alpha angle. This is your theta. How do I find the alpha? Alpha is equal to theta minus 180. So if this is in the second quadrant, 180 minus theta. If it's in the third, it's just a reverse, theta minus 180. So if this is like 250 degrees, because this is going to go from 180 to 270, right? So if this was, say, like 250 degrees, 250 minus 180, my reference angle is 70. This angle right in here would be 70. Finally, if we're in the last one, over here, I just down. We're over here, and we want to find that. Let's see, I draw it like this. Again, that's an awfully big angle. That's our alpha. That's our theta. What am I saying? That's our theta. What's our alpha? Our alpha is from here to here. It'd be a right angle. So that's our alpha. Our alpha angle is right there. And alpha, in this case, is going to be, because this is a very big angle, it's in the, from 270 to 360. We're going to use 360 minus theta. And again, the cosine and the secant would be the only positive ones. So let's go through this. This angle, if it's in the first quadrant, we don't worry about it. Second quadrant, 180 minus theta. Third quadrant, theta minus 180. Fourth quadrant, 360 minus theta. Will get us to our number. Okay, you say, well, that's great, but what if we have this angle right here? What is our reference angle for 1,000 angles? 1,387 degrees. Oh, fuck. And I want to find the reference angle for this. Well, that's weird to say that this is going around and around and around, and where she stops, nobody knows. Okay, so we will know though, because we're going to figure it out. So, first of all, we know it's going to go around one time. We know it's going to go around at least twice. Double that, and that's 720. So if we subtract 720 from this, it's a big angle. Goes around 3 times, we had 362. 62 is 8, 1080. That would be 1 time around, 2 times around, 3 times around. So let's subtract off 1000. Okay. You understand why we're subtracting that? So that would be 703. Our angle is 307. It's way over here. Oops, here. 307. That's our theta. We want to find our alpha. All we got to do is alpha is the angle. Sometimes they call it theta, but our angle that we're looking for, they sometimes put theta prime or something. But our angle, we call it alpha, is 360 minus 307. Our angle that we're trying to figure out, our reference angle, is 7 from 10 is 3, and this would be 53 degrees, I think. And that would be our reference angle, 53 degrees. So that's how we would calculate it. Okay. So let's use some nice angles, and we're going to use our little chart to help us out. If you remember the chart we had last time, you figured it out for 30, 60, 45. But let's suppose our angle, it's a nice angle, it's 210 degrees. But we want to figure this one out. So in the first quadrant, nothing. Let's do it this way. 1. Alpha. Second angle. If it's in the second quadrant, what was it? It was 180 minus alpha, or theta. Either way. Third angle, third quadrant, theta minus 180. And fourth quadrant, 360. You want to get these down, minus theta. So this angle is 210. This is 0 to 90. This is 90 to 180. We see it's bigger than that. This is 180 to 270. And this is 270 to 360. So we see our angle falls into this category. So we're going to subtract off 180, 30 degrees angle. So this is equal to 30. So we want to find our functions of 2tan, cosine of 2tan, tangent of 2tan, cotangent of 2tan. What else do we want to find? Secant 2tan. And these are degrees. Cosecant 2tan. Pretty cool. So we want to find that. So that is equal to. But what about in this quadrant? We're in the third quadrant. Only the tangent is going to be positive and the cotangent. Those will be positive. Let's put a little plus signs. These are going to come out negative. So this is going to equal the negative sine of 30. What is the sine of 30? Here's your reference chart. See, that's why I told you to make it. So that should be negative 1/2. I'm referring to mine. Okay, equals. Okay, this would still be negative cosine 30 degrees. What's the cosine? And after a while, you have these memorized. Negative radical 3 over 2, because we're going to use them quite a bit. What about the tangent? Well, that's going to be positive. That would be the positive tangent of 30. All students, negative. Take calculus. Okay, so that's going to be positive, and this would be 1 over the square root of 3, or radical 3 over 3. Okay, the cotangent, I had written it down. That's going to be positive. That's equal to the cotangent of 30 degrees, which is radical 3. The secant is going to be negative secant 30. And on my paper, I had 2 radical 3 over 3. You know, you can figure it out, but you don't want to do it every time. And finally, the cosecant will be negative also. Cosecant of 30. What's the cosecant of 30? 2. Negative 2. And I better put a negative sign here. So these are the only ones that are positive, see? And that's how we kind of do that. We kind of determine the angle, what quadrants it's in, and then we work it out like that. Pretty nifty, huh? Pretty nifty. Okay, let's try another one. What if I have the cosine of negative 240? Going this way. Well, what that would be is 240 plus a negative 240 plus, erase this out, excuse me, 360 minus 240, that's 120 degree angle. 120 is in here. Reference angle, 180 minus 120, 60 degrees. How, you know, if you do it backwards, you subtract this like this, what's going to happen? You're just going to get a negative 60, you know, and we don't want a negative angle, so we know it's going to be positive. So this is 180 minus 120. Our reference angle is 60. Now we can find them all, okay? But in this quadrant, sine, sine, cosine, tangent, cotangent, secant, cosecant. And this is 240. Let me try this cosine. And this was negative 240. But we know we don't want to go down to the 120. That's the same thing as 60. So the sine is 60. We're in the second quadrant. That's going to be positive. And so is the cosecant. But all the rest, 60, 60, 60, these are going to be negative. Cosine, tangent, and so on. Okay, so does this make sense? These are only 2 positive. So this answer is going to come out positive. Sine is 60, same as the cosine of 1/2. I think that's radical 3 over 2. Okay, without even using it. So this one would have to be the half, or opposites of each other, but this one came out negative. And the tangent is radical 3 over 3. No, 60 is radical 3. But that came out negative. And then we can find the rest of these going down. But it kind of gives you the idea. So you can kind of see, kind of nifty. Did I do them right? Let's see, 210. I used 240. Did I use 210 or did I use 240? I used 240. The book has an example with 210, but I used 240. So I did a little different than one in the book, so you get an idea how they're done. You can kind of look at the example in the book on page 57. Okay, find the exact value of the following expression. Well, we wanted to find the cosine of negative 240. Well, we just did it. Okay, we figured out it would be 60 cosine of negative 240. We know that that's 120. You know, 120 is the same thing as 60. But if it ends up 120, it was negative, so it should be negative 1/2. We already figured that one out. Let's try another one. How about the tangent of 675? Too big, let's subtract 360 from it. Okay, it's in the third quadrant. Reference angle, 360 minus 315, 45-degree angle. So basically the tangent of 675 is the same as the tangent of 45, except it's going to be negative in that because it's in the third quadrant, the fourth quadrant, and the tangent is negative. So what is the tangent of 45? Tangent of 45 is radical 2 over 2, and it's going to come out negative because we know where it's at. Did I get it right? 315. Tangent of 45. I was reading at the cosine. Negative 1. Excuse me. So that's why I want to use the chart. Let's do a toughie. Oh, God. Cosine. This is, if you have your book, example 4. 120 plus 2 sine squared 60 minus tangent squared 30. Oh my goodness. Cosine 120, reference angle 120 from 180, 60. Cosine is going to be negative, so this is negative cosine 60. So I'm always thinking A, S, T, C. All students take calculus. Okay, what's the cosine of 60? I cheat, I look at my little chart. 60 is 1/2, so this is negative 1/2. Plus 2 sine squared 60. Okay, well, we just figured out the sine is going to be positive. This will be 2 sine squared 60 will be 2 times, and the sine of 60, what's the sine of 60? The sine of 60 is radical 3 over 2, and I have to square that. Okay, so I got that. Then minus the tangent square. Well, unfortunately, 30 is a nice reference angle. The tangent of 30 is, unfortunately, radical 3 over 3. Tangent squared 30 is radical 3 over 3 squared. So now what do I got? I got a mess here on my hands. I got negative 1/2 plus 2 times. This will be square root of 3 times square root of 3 is 3. 2 times 2 is 4. Minus 3 times 3 is 9. Square root of 9 is 3 over 9. Hope you like fractions. 3 over 9, well, 3 over 9 is 1/3. What's reduced? 1/3. So how am I going to add all this up? Now let's see. First, well, let's do this extra step. Negative 1/2 plus 6/4 minus 1/3. I need a common denominator, something that they would all go into. And could I use 6? No, 4 won't go into 6. How about 12? Throw out divided 12. So to get 12, I'm going to multiply this by 6, top by 6. Negative 6/12. You get 12 here, I'm going to multiply by 3 and 3. 18 12s. Plus, I'm going to write this as a negative. Here I'm going to use 4 times 4. 4 12s. So this would be a negative 10 from 18 would give me a 8 12s. I have to reduce it by 4. 4 would go into both of those numbers. 4 and 8 is 2. 4 and 12 is 3. 2/3. Isn't that easy? Story. Yes, it is kind of hard. Evaluate each, okay, let's look at the next one. Evaluate each function by first expressing the terms in a function of an angle between 0 and 360. Isn't that what we just did? Let's see. This is example 5. Oh, is an angle between 0 and 360. So they gave us the cosine of 780. I don't know. I would just subtract 360 from it. 420, too big. Subtract 360 again. Our reference angle would be the cosine of 60. Cosine of 60, and that would be, you're going around once, you're going down twice, and you're ending up in the first quadrant. It's 60. So the cosine of 60, what is the cosine of 60? 1/2. No, we've done that before. That doesn't look too hard. Anything else we need to know? Oh, okay. Let's look at the very last problem, example 6. It says, find all the values between 0 and 360. Great. And they told us that cosine of theta equals a negative radical 2 over 2. Okay, so first of all, this negative sign. This negative sign is telling me that the cosine isn't going to be in the first quadrant or the second quadrant, the fourth quadrant. The cosine is negative in the second quadrant and the third. So we're looking for angles in the second and third. Now, we know that negative 2 over 2, what is negative 2 over 2? That's going to be a 45-degree angle. So, but that's in the first quadrant. That's not our angle. The angle we're looking for is either in the second quadrant. So in the second quadrant, we're going to add 45 plus 180. It's going to be 225 degrees. Well, what about in the third quadrant? I mean, how do we figure it out in the third quadrant? Because it's going to be in the third quadrant. So in the third, well, I guess we were in the third quadrant. This is the third. What about the second quadrant? Second quadrant, we subtract from 180. Got ahead of myself. 4. That's a 7. 135? Yes. So the angle we're looking for is either 225 or 135. We add for the third, we subtract for the second. Sorry. So this angle, and it said it had to be between 0 and 360. These angles are between 0 and 360. This is our reference angle, but the actual angle is, it's kind of the reverse of what we're doing. We have the reference, we're trying to find the actual angles. Well, I can go on for hours now, but I'm sorry that I can't listen for hours. So I appreciate you listening to me, but let's get out of here. Thank you for watching. Stay healthy, stay safe.